Alright, so this is our window washer problem. The problem gives us a bunch of lengths and distances, which you can hopefully see in your diagram. And also the weights of each of the objects and people. It's important when you see a weight like 395 newtons to realize that is Fg. You don't have to multiply it by 10 because it's already in newtons. Okay, so once again, the first thing we're going to do is start out by drawing a torque force body diagram. So I have my board. Okay, there's gravity from the board, and it's going to come right out of the center. So Fg board. And then I have at 1 meter, Bob is standing, and his gravity weighs down Fg Bob. I have a bucket at some point, so Fg bucket. And I also have Joe. Okay, so that's that's a J. F, G, Joe. The other two forces I have are my two tensions. So I'm going to call these tension 1 and tension 2. I want to find these two guys. That's what I want to find overall. Okay, and what that means is I probably want to pick one of them as my pivot point because it'll save me some algebra. So I'm going to pick T1 as my pivot point. This is my torque. I'm going to draw another diagram for force. So I'm just taking this torque body diagram and collapsing it onto a dot. Up I have T1 and T2. They're both going up. And then all of these other things going down. Doop, doop, doop. Fg Bob. Fg board. Fg Joe. Fg bucket. Okay, the main difference between these is that this torque body diagram shows me where on the object the forces are, and this just says, well, all the forces have to equal out to 0 at the end, regardless of where they are. Okay, now I'm going to write out my torque equation. If you notice, all of these angles are 90 degrees. Okay, so the equation for torque equals F R sine theta. Okay, but all of my angles are 90, so this is just equal to 1. Not even gonna put that into my torque equation. Okay, so I know the net torque equals 0. I don't care about T1 because it's at the pivot point, so the radius is 0. And I have Fg Bob, and Bob is his radius. Okay, that's going to be going down, minus Fg board, our board, minus Fg bucket, our bucket, minus Fg Joe, can't see this, our Joe, and then the only positive one is tension 2 R T2. Okay, all those things have to equal to 0. I have numbers for most of these things. Okay, so it says up here, Bob weighs 805, so minus 805. Bob's radius is 1. Okay, minus the weight of the board, which is 395, and it's from the center of the board. The whole board is 3, so the center of the board is at 1.5 meters. Minus the bucket. How much does the bucket weigh? 500. The radius of the bucket is 2 meters, and Joe is 0.5 meters from the other end, so his radius is 2.5 meters, and it says that he is slightly fatter at 820 newtons plus T2 times 3 meters. Okay, at this point I can find all of these numbers and just solve for T2. So, you should go ahead and try to do that. I have negative 805 plus negative 805 plus 395 times 1.5 minus 1000 minus 820 times 2.5 and that's about negative 4447.5, or plus 3T2 equals 0, T2 equals negative 4447.5 divided by 3, T2 is equal to 1482.5. Okay. Now I have solved for T2. I go back to T1, and I know that T1, so I'm taking the sum of Fy equals 0, so up minus down, T1 plus T2 minus Fg Bob minus Fg board minus Fg Joe minus Fg bucket equals 0. Okay. I have a number for T2, so T1 plus 1482.5 minus all of these weights, so 395, 500, minus 805, minus 820 equals 0. Okay, and then you're just going to add these guys all up. So we have 1482.5 minus 395 minus 100 minus 805 minus 820. Okay, and you get T1 minus 1037.5 equals 0. T1 equals 1037.5. Okay, and that's your answer. We have T1 and T2. That's all we wanted to find.